So welcome to our notes on piecewise functions, and on the front of the notes booklet we have some vocabulary we want to discuss before we get into the examples inside. A function defined by multiple subfunctions, right? Subfunctions is what a piecewise function is, and when we look at this example of a piecewise function f of x, it's comprised of these three subfunctions: x plus 4, 1/2 x squared, and -2 square root of the quantity x minus 2 plus 1. Okay, it looks messy in here, but if you locate where the comma is in the row, so x plus 4 comma, everything before the comma is the subfunction. So there's a subfunction of x plus 4. Okay, anything after the subfunction is referred to as the subdomain. So f of x itself, which is all three of these pieces, it has its own domain, right? But each of these subfunctions has what's called a subdomain, right? Each subfunction applying to a certain interval of the main function's domain called a subdomain. And the subdomain is after the comma. So we have a subfunction of 1/2 x squared here, and that's before the comma, and then that subfunction is only existing in the interval between -2 and +2 inclusive. Okay, then in this third row we have a subfunction right before the comma, so -2 square root of the quantity x minus 2 plus 1, and it is over the restricted subdomain here of x's that are strictly greater than 2. Okay, these pieces can be any type of function. So if you're going to sketch their graph, you want to try using transformations to graph them. Okay, for example, this x plus 4, this is a linear parent graph shifted up 4. 1/2 x squared, that's the parent graph of our quadratic function, the parabola with a vertical shrink of 1/2. And then the square root subfunction in the third row has been translated up 1 to the right 2, reflected in the x-axis, and a vertical stretch of 2, right? We learned all of that in Unit 1 when we were studying transformations. Okay, then we'll use open and closed circles to indicate if endpoints are included in the domain. That was also covered in Unit 1. So whenever there's an equals in our subdomain, for example, here -2 is less than or equal to x, right? X is less than or equal to 2. Those would be closed circle endpoints. But the other subdomains, x strictly less than -2, x strictly greater than 2, those would be open circles because there's no equals. And piecewise functions can be continuous, or they can have any of the discontinuities that we talked about in our last lesson. So let's go ahead and take a look at example 1 together. And here's our function that we were just looking at in the front of the notes, where there's an x plus 4 over the interval x less than -2, right? We've got a 1/2 x squared over the interval between -2 and 2 inclusive, and then our square root subfunction defined for x is strictly greater than 2. So if I want to evaluate this piecewise function for f of 6, okay, that 6 is the x value. It's the input into the function. And I have to decide which of these subfunctions I can use to evaluate that f of 6. So remember, anything after the comma is part of the subdomain. So is 6 less than -2? And that answer is no. So then I look at the next one, and those are x's defined from -2 to 2 inclusive. Is 6 between -2 and 2? And that answer is no. So then I look at the next subdomain, and is 6 strictly greater than 2? That answer is yes. So I'm going to use this function in the front here of that subdomain. So everything in front of the comma is the subfunction, and because 6 is greater than 2, I'm going to substitute that 6 in here for x. So I have a -2 square root of 6 minus 2. Okay, then that quantity is plus 1. And that's going to give us a, well, let's fix that equal sign. That's a little rough looking. There we go. That's going to give us the square root of 6 minus 2, which is 4. So square root of 4 is 2, times negative 2 is negative 4, plus 1 is negative 3. So f of 6 evaluates to equal negative 3. That's the y that I get out when I put in a 6 for my x into this piecewise function. So now we're going to look to evaluate f of negative 12, right? Negative 12 is the x, and I look to see where is that going to work in my piecewise function. So is negative 12 less than negative 2? And that answer is yes. So I'm going to substitute negative 12 into this linear subfunction. So I put in a negative 12 for the x, then that's plus 4, and negative 12 plus 4 equals negative 8. And then f of 3 halves. 3 halves is 1.5. So when I look at my subdomains here, 1.5 would be between negative 2 and 2. So I'm going to substitute it into this quadratic subfunction. 1/2 times, but instead of x, I put in the 3 over 2, and then that gets squared. So that's equal to 1/2 times 9 over 4, because I square the 3 and then I square the 2. And then when we multiply fractions, we multiply straight across the numerator. 1 times 9 is 9, and straight across the denominators, 2 times 4 is 8. And so 9/8 would be the y value when I substitute 3 halves into my function f. Okay, now in example B, we want to also evaluate these functions, but we have to use the graph because we're not given the equations. So if I'm asked to evaluate f of negative 2, right, then I know this negative 2 in the parentheses, that is the x value. Okay, what I get back after I do that, evaluating f of negative 2, that's the y value. So I'm going to look along my x-axis for negative 2. Here's my negative 2 on the x-axis. Now I look up to find where is that point on the function, and it's right here. And the y value that goes with it is 4. So I input a negative 2. My output is a positive 4. So f of negative 2 equals 4. Okay, then f of negative 6. Negative 6 is my input. So I come over here and find negative 6 on the x-axis. Then I head for the function, but what happens when I get to it is I run into this open circle. I can't bother going across to find the y at that open circle because the function is undefined there. There is no y value because it's an open circle. So f of negative 6 is undefined, which you can use this 0 with a slash through it, means undefined, or the empty set, which is squiggly braces with nothing between them, that also means undefined. Or you could write undefined, right? All of those mean that there is no output for that input in the function. Okay, next we have f of 0. So I go to 0 on the x-axis. Here's my point. That is defined, and my output is 0 because that's the origin, 0, 0. Okay, then we're going to put in a 1 for our x. So we come over here to the x-axis, we find the 1. Now if I were to go up to meet the function, I would run into an open circle, which is undefined. But if I go down to meet the function, I run into this closed circle here where the y is negative 2, right? And closed circles are always the answer if you have both an open and closed, right? We wouldn't pick an undefined place on the graph to give our answer. So we use this closed circle, and that means f of 1 evaluates to be negative 2.